Sorry about that. Good evening, everyone, and thanks for joining for our third Colombo IoT meetup. And let's start this session on XBee communication module. Uh, First, let's uh, look back at our previous meetups for a moment. Colombo IoT ignited the IoT fire in Sri Lanka with the first IoT meetup. Get ready for the future. Then we deep dived into IoT with our second meetup, and now we are here in third meetup with the intention of expanding our reach. Here we are not only sharing the knowledge on how to expand your IoT projects through communication, but also have the intention of extending our reach to a larger group of IoTers in Sri Lanka. If I summarize today's session so far, we were able to grab all the aspects of IoT communication, where our first session covered the broad range of communication possibilities available for IoT, and the second covered that how to connect IoT devices to a gateway with a working demo also. And the third session covered how IoTs can materialize their usage of their devices and expose them to the world as APIs. And now I will cover how we can expand the range and make our IoT devices limitless through XBee modules. Let's take an example. Typically a weather station, because I work with the guys who work for Common IoT project, so a little bit familiar about that. Let's take an example of weather station, and you have completed your prototyping of your device, and now your device is in the working state, and you have connected it to your PC with the data cable, and you have tested your system. Now you want to move to the next level. Next level will be implementing the weather station in the real world. So the first thing you might need to get rid of this data cable connecting the device to your PC or the server. So for that you might need a way to communicate between these two using a wireless connection. So I think in the first session Damit mentions that there's a huge range of options available for this purpose, and you can select one of those based on the requirement. So we'll say since this is a weather station, you might need to deploy it in very remote areas where the GPRS signals are not available, the mobile network coverage is not available. So you have to scope down, eliminating the GPRS modules, GSM modules, and also you might need a better range to communicate. So Wi-Fi and Bluetooth might not work for you. So the ideal situation might be to use some kind of radio frequency modules. So with these sessions I'm using XBee to explain it. So let's use two XBees. And now instead of the cable, now you have integrated an XBee to your device, and also to the another XBee to the server. now you easily now you can easily implement your weather station in the real world. And we'll say now you have implemented your first device, and now you need to expand. So to achieve weather station's full potential, you might need to deploy many devices in different geographical areas. So what you can do is, now since you have integrated XBees into your weather station, you can have many weather stations deployed in several geographical areas, and let them connect with your server and work as a network. So here's how it happened. And further, you might need to expand your project, and you might need to deploy your weather station around Sri Lanka. So you might need to have your device set up in every district of your every district of Sri Lanka, and you might need to work those devices deployed in particular district as a group, and also you want all the devices connect back to a central location also. So you can easily come up with this kind of scenario where these the some of your devices can work as routers for that district, and they can communicate with your center server, and that center server will be connected to your cloud. And so so now you see how XBee modules can expand your prototype to a large scale IoT implementation without making your device much complex. So that's what I want to highlight here. And let's talk about the XBees. Now these definitions are there in the internet, and you can search about the technologies and the details of it very easily. It's readily available. So I will not go into the theories and the details about these modules. I'll more focus on the practical aspect of this. I'll introduce XBee as a IoT devices friendly radio frequency modules which supports various protocols and signal frequencies. So and out of the ZigBee range of modules, XBee range of modules, ZigBee based XBee modules are the most popular since they are ideal for building up these IoT networks. And this is a comparison of different modules available. I don't think you can read it, but you can easily get these comparison if you browse the web. So the most important thing I need to highlight here is that different modules have different capabilities. So these XBees have range from like 300 feet to 28 miles. The XBee Pros are going to that extent. So depending on your need, you can pick up the module, and it also coming with different protocols. So based on the requirement for the security level you need, or the implementation easiness, you can use you can pick up a module very easily. So when we talk about XBee modules, there are two main modes of communication you can configure to your XBees when deploying to your IoT projects. So one is AT mode, the other one is API mode. So AT mode is the simplest way, which is coming as default for XBee modules, which act as a USB cable. So in AT mode, two XBees communicate with each other using the serial interface, and whatever the data received into the serial interface will transfer to the other ZigBee instantly. Since it uses the serial interface heavily, it might be difficult to interrupt the communication, and when you need to send a control command or something, it's a little bit difficult. So on the other hand, we have API mode, which gives more control over the communication, and also you can build complex IoT networks. And now XBee modules which uses ZigBee protocol will enable to build a complex network for IoT device. With IoT networks, we can achieve greater coverage while having control and high availability. So there are three types we can configure XBee modules to act in a network. So those three are coordinator, router, and end device. So in the diagram, you can see manage the network itself, and we need to power it with a stable power source. Otherwise, if the coordinator goes down, whole network will go down. And then we have routers which act as in between communicators. It not needed to be special communicating only device. You can have your one of your device as work as a router by adding a XBee and configure it as a router XBee. And you have the end devices. So end devices are basically the end weather. If we take the weather station, those are the weather station deployed in rural areas. So those can be programmed to communicate only when they need it. So they can go to sleep for power saving, and when the communication is needed, the device can reconnect to the network and send the data. But routers and coordinators always need to be active. Okay. So why we need these XBee networks? It helps to extend the range of our deployment, and also enhance the coverage. We can enhance the coverage. So you can see in this diagram, I have added two routers to one node, one branch of the network. So we'll say each the communication distance between each two modules are 2 miles. So I have extended it to 6 miles range using several routers. So you can so time is flying. And IoT IoT networks enables you to have the high availability of IoT implementation. I'll show how you do it. Now in this situation, we'll say one of your routers get down, and it is disabled, and all the devices connected to it will disconnected from the network. But with ZigBee, you can configure it to connect to the network if the current network connection is broken. So it will look for the devices, routers within its range and connects to another router which is available. So that way you can maintain your high availability in your IoT projects. So again, these are some of the first image is simple Wi-Fi based XBee module, and the other one is XBee Pro module, which has 28 miles range RF modules. And so I'll skip this because this kind of comparisons are available in the web if you search for it. So you the main thing I want to highlight is based on the requirement of your project, you have to do the smart selection of your XBee. You don't need to spend a lot on long range XBees while you can have low end XBees and make a network and do the same. So it depends all on your requirement. So there's a huge range of XBees available, so you can pick the right one. So to connect these XBees to your devices and to configure, you need adapters and XBee kits, and you can connect them to FTDI cables for configuration, and to connect with your development boards. There are several shields available. So here it shows Arduino shield and XBee adapter. So I have bring two modules and some adapters to demo you the how to connect it to the how to make a connection between two devices. But I think I have to move it to the later because the time is restricted. So I'll move to the software side of it. So you can configure your XBees through command line configurations, but it's little bit difficult when you are working on a prototype project, and you might need to find a easier way. So there's a way. It's called XCTU, which also provided by the company who developed these XBees. You can freely download and use it. So I'll show you how to connect and show you the basics of XBee module, so you can understand and how to do the networking. So here we have XBee module mounted on a XBee adapter, and I can plug that adapter to my PC. And I can use that XCTU software to create this module. So this is the XTU. We can search the connected XBees through this. So we can read the configurations from the current configuration of the XBee through the tool. I told you that XBee has two communication modes, AT and API, and also we can set up them as coordinators, routers, and in the devices. So we can do that through this software. We can program it. So let's try to this is in now the module is in the ZigBee end device API mode. So I can change this. I can update the firmware. So I'll make it a API based coordinator. So that's the that's a must have for making your IoT network. So it updates the now there's another technical difficulty. So this module I have the adapter doesn't have a preset button. There's another version we have a reset button. So I have to hard reset this using reset node and the ground pin. So I'm not going to do that right now. Let's try the other module. So no, it says updated successfully. Here's the now the module is in the ZigBee coordinator API mode, and you can see the configurations here. So this PAN ID is the personal area network ID is the key to make a network. So you can specify your own PAN ID, and you have to specify the same PAN ID for all your ZigBees in the network, and that's how those ZigBees identify your network. It adds the security also, because another outside device cannot easily connect without knowing the PAN ID. And also you can set the SC channel, so it restricts the connectivity further for that particular channel. And you have this SH and SL, serial number high and serial number low. These are together these values make a unique ID for your ZigBee, the ZigBee module. So you can easily identify your ZigBee module through this ID. It is a static ID for that particular module. And you can have destination high address and destination low address. So where you define a range of addresses that can connect to the coordinator. So anything outside of this range will not be connected. So it adds the security and security for your IoT project. So I'll move on and show you the demo afterwards. So anybody interested, we can talk with me. And I use investigate on this module because of the Colombo IoT project. So we had a issue that we need to have the connectivity between our devices. So I think now Lahiru and others have come up with a better solution. So let's go back to the presentation. So anyway, when you are programming your XBee adapters, you need to first figure out what is the type of network you need to build up. So based on that, you have to think what device need to be a router, what device need to be a end device, and which one need to be the coordinator. And what is the benefit as IoT, as having using the XBees? There's a large range of modules enable you to implement right solution for your IoT project, and modules used for prototyping can be used for final implementation also, because they are robust and you can use the same modules. And lot of resources available due to its popularity. Especially the XBee based XBees, and can create complex IoT networks which are easily enable robust, reliable and high available IoT implementations. So that concludes my session for the day, and I have 2 questions. I'll quickly go through them. So first question is, what are the 2 main modes of communication XBee modules can use?
AT-API.
Sorry?
AT-API.
And the next question is, what are the 3 types we can set up XBee modules into when building a wireless network? Right. So thank you everybody for listening.